Welcome back to Cardano for podcast number 2. Today we're going to be talking about Marlowe and Plutus and smart contracts just in general, how they fit into the Cardano ecosystem. But before we get started, if you like what I do, you want to support my channel, if you have ADA, you can jump into my my ADA pool that I'm running, code name Sophie, S-O-P-H-I, named after my daughter Sophia. Or else I have an ADA address there for any kind of support. I'm also going to have something, I don't know, I'm going to join one of these other programs, I guess, where you can support. I don't know a whole lot about it. I'm just starting, but I'll have something else too down in the messages down there where if you want to, you can jump in there too. Okay, so let's get back to smart contracts. Today I sat down, or actually yesterday I sat down and I watched one of the hours at the IOHK Summit. I watched a gentleman by the name of Philip Wadler. He teaches at the University of Edinburgh and works for IOHK. Side note, Edinburgh is a beautiful town. There's a castle like right in the middle, and it's on a big hill, so wherever you are in the town or city, I don't know what they call it over there in Scotland, you can see it. It's like at the highest point. It's really pretty cool. If you ever get there, it's a really cool town to go to. And they have a bar there that's just vodka. All vodka. I don't know if it's still there. This was years ago, but I don't drink vodka anymore. But when I did, it was a cool bar. Okay, so let's get into the smart contracts here. So I watched Philip's video. I watched about half of it. I plan on watching the whole thing, but there's so much information. I don't want this video to be super long, and I kind of want to go over everything on a high level. So we're going to keep this video hopefully to under 20 minutes, 15, 20 minutes, and kind of just touch on Marlowe, Plutus, and kind of how they fit into the ecosphere. Okay, so first let's talk about Cardano. What drew me to the project? What drew me to the project is the way they research everything. So Cardano, at the time when I looked at this, and I think they still are, but this was a couple of years ago, everything they do is peer-reviewed, and it's published. So like medical journals, doctors publish in medical journals. Cardano is the same thing, except they publish in technical journals. Yeah, everything is done peer-reviewed. So before they write a lick of code, and before they wrote the code even for the blockchain here, they researched, they did the math, they had everything, they wrote, and they had everything peer-reviewed and published in journals. So it really kind of drew me to Cardano because of that. And along with the base code, they did the same thing for the smart contracts. So what they decided to use in the smart contracts to create the smart contract language, right, was Haskell. It's a programming language called Haskell. Haskell has been around since the 80s, the late 80s. It's used primarily in banks and financial institutions, which should ring some bells, right? It's a solid language. It's been through the ringer. So that's the language they decided to build their two platforms in, Plutus and Marlowe. And the reason is because it's a solid language and banks use it. You can program it quickly and it's reliable. I'm looking at notes here a little bit too here while I'm talking, so if you see me look down. And why did they use a reliable language, right? Why did they want to use Haskell, something that's been around for a while and it's really reliable? Well, it kind of goes back to Ethereum, right? Let's talk about Ethereum for a little while and their smart contracts. Ethereum did a few things. One thing that was absolutely wonderful was that it showed that there is a market for smart contracts. I mean, they're all over the place now in this kind of ecosphere. People use it for DeFi, for so many different things, right? That was the main thing that it showed. The second thing it showed, which we should have known, is that people will try to figure out a way to steal your money. In the old days, it was by robbing horses and carriages. Now, it's by trying to hack smart contracts, right? So Ethereum uses this language called Solidity. Solidity is not the, I don't know, how do I say this, the securest language in the world. If we take a look, I just pulled this up as a reference. I'm not going to go through the whole thing, but if we take a look at this here, this was something that was written in the Journal of Networking and Distributed Computing. This is about vulnerabilities in smart contracts, and we'll just skip down to the findings here. So if we look at the first paragraph. In this section, we briefly describe all the Solidity bugs we collected that fell into the BF classifications in terms of their causes, attributes, codes, etc., etc., etc. But if you look here, you just see there's a kind of a big list here of vulnerabilities and bugs. And then down here they go on to explain a lot of these bugs. And when they happen, the consequences or whatnot. I'll link this down below so you can take a look at it if you want to dig into it. I just wanted to kind of show that real quick. So this is the reason why when IOHK and Charles and the people over there at IOHK decided to build a language or build a smart contract language or platform, they decided to go with Haskell because it's secure and kind of tested. And when you're transferring tens of millions of money or ADA or Ether or whatever it is you're transferring, you want to have a secure code, secure language, right? I mean, it just, makes sense. Excuse that. Sorry about that. Okay, so let's move on here to Marlowe. We're going to start with Marlowe. Marlowe is a really cool language. So they built Marlowe to be used by anyone. The guys and gals over at Haskell, over at IOHK, they got together with a company called Dion Digital. You'll see it here in this this slide or whatever you want to call it. Dion Digital had this approach where what they wanted to do is they instead of having a bunch of people work on something, they wanted to make it so one person could do everything. So IOHK decided to incorporate this approach in Marlowe. They wanted Marlowe to be a platform where a banker, a lawyer, an accountant, anyone could come up to it, have an idea in their head, and make this smart contract without having a developer there or having to tell a developer to make it. So if you look at this slide, I'll call it, you'll see here they have three people. Business analyst, they call the first person. This is the person who comes up the contract. We want the contract to do this, this, and this, charge this and this, when this and this happens, right? The next person here is the developer. This is a person that you would talk to create this contract, to actually program the contract. And then the last person you have here would be a person who puts it through its paces, right? Checks it out, tests it, holes, what have you. Just make sure it works before it's deployed. You remember, blockchain is an immutable chain or immutable database, right? So you want to make sure you get it right the first time. What Marlowe does great is it combines this all into one person. So now you don't have to be a developer, right, to make a Marlowe contract. And you may be asking, well, then how is someone who's not a developer going to be able to make a contract? Right? All right, now let's take a look at this. Now, if you have kids, you might notice on the left-hand side code that looks kind of familiar. There's a kids coding platform, I think called Scratch, where you drag blocks and you make code. That's how they make code. That's how they learn it. My daughter's 8. That's what she's learning how to code like that. Now, that's what the Marlowe is the same way. So you can make these contracts just by dragging blocks around. So instead of having to hire, a developer for a couple $100,000 a year, or pay a developer every time you want to make a contract, you could hire a company to say, come train your staff, right, for a week or two. Then all of a sudden they know how to make these contracts. It's wonderful. It's genius. It's a great idea. It's going to get people using Cardano and using Marlowe right out the gate. It's just a really ingenious way of doing this. If you look at this here, so on the left-hand side, you see what looks like a Scratch platform, or this is a drag-and-drop platform to make the contracts. On the right side, the upper part here, that's Haskell. So if you know Haskell, you could still dig in here and create this with Haskell or fix it up or whatever you want to do. I'm not going to go into this any more than this right here. My next video, I think I'm going to do it on Marlowe. I think I'll get maybe a live version working, go to the Marlowe Playground. So you can go now to the Marlowe Playground on I forget whose website it's on, but you can go to the playground now and play around with it. Just Google Marlowe Playground. I'm probably going to do that for the next video so we can play around with it a little bit. For this video, I don't want it to get too long, and I just kind of want to give an overview. So we're going to move on from Marlowe to Plutus. Okay, so to talk about Plutus, let's go again back to Ethereum and Solidity. Now, I'm not trying to pick on Ethereum here. I'm really not. Ethereum is the reason I believe that Cardano exists. I mean, they came up with a great platform. Millions of people are using it. Millions, I guess, right? I don't know. A lot of people are using it. And I don't think ADA would be here, or Cardano, or maybe even IOHK wouldn't be here without Ethereum. But the reason I'm comparing this so much to Ethereum is because there's no one else really to compare it to. Ethereum is the best and most well-known smart contract platform. And Solidity is the most well-known smart contract programming language. There are some other languages, but Solidity is the one that most people use. Okay, so let's go back to Solidity. When you build a contract in Solidity, you can build it on a program called Remix, and you can test it on Remix. It's fine. But when you want to take that contract and kind of bring it to the masses and put it in an app, you have to combine that with JavaScript and with another library, W3 library, and there's a couple other things you got to put in there. You got to make the JavaScript and the Solidity contract talk to each other, right? So the person on the web putting the numbers into the contract or putting it in through JavaScript is putting that into the contract. And then the contract is then going to the blockchain and doing its thing, right? So that's kind of the way it works. They didn't want to do that with Cardano. IOHK said we don't want to have to deal with these contracts, all this stuff talking to each other. They want to do it. They want to do something different. So this is what they did. So we're going to look at this here. So for the people that know Haskell, this will look familiar. This will all look like Haskell. But what this is, essentially, think of the blue on the bottom like a Solidity contract, right? And the green on the top is like the JavaScript, except it's all in the same program. The top is Haskell, pure Haskell. The bottom is something called Plutus Plutus TX, and I believe they called it like a library. But it's Haskell. It's also Haskell. I think I heard someone refer to it as kind of like Haskell Lite. I mean, it's not full Haskell, but it's pretty much Haskell. If you know Haskell, you should be able to pick this up really quickly. So what's really cool about this is you just write the one program. You don't have to write JavaScript. You don't have to combine it with anything. You're not using another library like W3 library. Everything is just right here. You just make it on one platform. Philip likes to say batteries included programming. I thought that was kind of a cool statement. He called it batteries included programming, and it really is. You just make it all at once on the same platform. So it's great. Okay, so the next thing I want to talk about a little about is gas. I'm going to let Philip do that, though. He explains it much better than I, and it has to do with the fact that Cardano is a UTXO system versus Ethereum, which is a account approach type of a system. So let me pull him up here, and we're going to listen to Philip explain this because he does a much better job than I do. And then we'll talk about it after he is done.
So another thing I want to talk, a very different way in which functional programming comes into this, is UTXO versus accounts. So Bitcoin and also Cardano make use of what's called UTXO, unspent transaction outputs, whereas Ethereum uses what's called an account-based way of doing things. And most people use the account-based way of doing things. It seems very natural, but there are actually some advantages to using unspent transaction outputs. So let's go over, here's a simple example of this. So here is a transaction. This is the origin transaction, and 6 ADA are created and given to Alice, and 4 ADA are created and given to Bob. And you can see that because these are outputs of transaction 0. So when they're not spent yet, they are unspent transaction outputs. So now Alice spends 3 of her ADA by giving them to Charles. She keeps 3 ADA for herself in this transaction. In this transaction, Bill gives 2 ADA to Charles and keeps 2 for himself. And you might think Charles already has enough ADA, but in fact they're using Charles here to adjudicate something. Charles is a mediator in this case, and Charles mediates and registers another transaction that says, in fact, of those 5 ADA, 2 should belong to Alice and 3 to Bill. So here we've got all these unspent transaction outputs, one that gives 3 to Alice, one that gives 2 to Alice, so Alice has a total of 5, one that gives 3 to Bill, Bob, and another that gives 2 to Bob, so that Bob has a total of 5. So that is the unspent transaction output way of doing things, UTXO. Here, down in the corner, is what it looks like in an account-based system. So we've got accounts for Alice, Bob, and Charles. And at the beginning, Alice has 6, and Bob has 4, Charles has nothing. And then Alice gives 3 to Charles, so now Alice has 3, Charles has 3. And then Bob gives 2 to Charles, so now Bob has 2, and Charles has a total of 5. And then finally, Charles gives 2 to Alice and 3 to Bob, so both Alice and Bob each have 5, and Charles has nothing. So that's what it looks like with account-based. You might think, oh, that's a lot simpler. But the thing about accounts is you don't know in what order these transactions will appear. So if they appear in some different order, so say this one appears before transaction 2, well, this says that Charles is giving away 5. Charles doesn't have 5 yet, so it becomes invalid. This transaction just doesn't happen. So the reason that UTXOs work so well is transaction 3 here specifically refers to transaction 1 and transaction 2. With UTXO, that's the way it works. And so you know exactly what transaction 3 is going to do. Transaction 3 has to come after these 2 because it refers to them. With accounts, it's just whatever order things happen in, and you don't know what's going to happen. So the result of that is under UTXO, you know exactly how much gas you're going to use. But under accounts, you don't know. Depending on the order things work, your transaction might be invalid, or it might be valid but use 10 or 20 or 30 gas. You don't know. So there's a real advantage to the UTXO approach, which people with functional programming will be familiar with, because everything just specifically refers to something else. You don't depend on the order in which things happen. And our name for that is deterministic.
So that's really interesting. So I didn't know that. I bet there's a lot of people using Ethereum would like to know that, especially now with gas prices this way. It's just kind of a crapshoot. Is it going to go through the right way? Is it going to take a little longer? Is it going to be 10, 20, 30? I thought that was really interesting. So, and he explains it much better than I ever could. Thank you, Philip. Okay, let's move on here. So we're going to end with the last little bit here. Give me a second to pull up my notes. Okay, so we're going to talk again one more time about Ethereum. Ethereum and Solidity. So Solidity, what it does is after you make the Solidity contract, it goes to something called the EVM, the Ethereum Virtual Machine, and that's what translates what you're writing into a language that the EVM understands and goes to the blockchain, right? So if we take a look at really quickly here, if we take a look at the Ethereum yellow paper, and I'm just going to scroll through this quickly. It's pretty long and a lot of math, a lot of stuff that I don't quite understand. And this is all has to do with the EVM, kind of explaining how it works. All this kind of good stuff here. I'm not going to go through this. I don't know why this is not working. So anyway, so you get the idea. It's a real long document here. A lot of information. The Plutus has something a lot like this, right? Except it's called the Plutus core, not the EVM, obviously. And the Plutus core is written in something called Lambda Celsius, calculus Celsius, Lambda calculus, right? Lambda calculus has been around for 50 or 60 years. It's got a really interesting, if you're into this kind of stuff, kind of progression. It's been discovered by 3 or 4 different people over the years. I don't want to get into it really, but it's interesting if you look up the history of lambda calculus. But the cool thing about lambda calculus is the whole language and the whole Plutus core that's written with lambda calculus, right, can fit on a napkin. So that there is Plutus, is the Plutus core right there. I don't understand the look of it. I don't understand any of that stuff. I don't understand the virtual machine EVM either. What I do know is that when you have something that's simpler or less parts, there's less, and this is a very simplistic view, but I like to break things down to kind of common sense. If you have 20 different parts, you may be able to build something that's really complex, right? You just use the parts over and over, and it's really complex, but you only have 20 parts, right? So how much can go wrong? If it goes wrong, it's kind of probably easy to fix or at least find, because there's only 20 different moving parts. If you have something that has a million moving parts, you can make something great, but if something goes wrong, again, how are you going to find it? There's more things to go wrong. There's more things to miss because there's more moving parts. And this is just the way I look at it in my head. It's kind of the analogy I use. I could be 100% off with this, but it just makes sense to me that something that has less moving parts, something that's simpler, is just going to work better and be easier to create, fix, and modify because there's not as many moving parts. And that is the Plutus core that Cardano uses. Everything kind of bakes into the Plutus core, just like from Solidity, everything kind of bakes into the EVM, Ethereum Virtual Machine. So I'm going to wrap everything up here by going back to the beginning and talking about real quick again how IOHK started from the beginning using science, math, peer-reviewed publications before they built anything. And it really shows now when you dig into this. The way things got put together, the languages they used, the Haskell, the reason they used them, banks used them, financial institutions used them. The Plutus core is broken down to something that's been around for 50 or 60 years based on math and science. It's got a great foundation. If Cardano has nothing else, it has a great foundation. It is like granite. When Charles says that, he's not lying, and I understand why he says that. So I'm going to wrap it up here. The next video on Tuesday, we're going to get into Marlowe a little bit, and we're going to play around with it and maybe dig a little deeper into that. And then going forward, I'm going to go through a couple more videos, a bunch more videos from the summit, and we're really going to dig into what's coming up with Cardano in the future. All right, so I'll say goodbye for now. Like I said, if you want to support me, Ada in the pool or Ada at the support address, that would be great. If not, or either way, please like the video, and I will see you next Thursday. Have a great day, great weekend. Goodbye.